Good day, viewers. Welcome to Charity Math class. In today's tutorial, we will be looking at this topic, special angles. You should know that this special angle is coming from the topic trigonometry. Now, we are going to look at the angle of 0 degree, 30 degree, 45 degree, 60 degree, and 90 degree angle. Of course, you know they are the special angles we are talking about. The first thing we are going to consider is the ratio of 45 degree. Now, in considering the ratio of 45 degree, we have to consider an isosceles right angle triangle with 1 unit length. Now, this isosceles right angle triangle, of course, you should know that a right angle triangle is a type of triangle that has one of the angles to be 90 degree. At least we're having 90 degree in here. So to becoming an isosceles right angle triangle, it means that this side is equal to this side. So we are considering 1 unit for the length. So here is 1 and here is 1. And this side being equal to this side, it means that the two base angles are equal, which means any angle here is equal to the angle here. And having known that the sum of the interior angles of a triangle is equal to 180, and this one is 90 degree, of course, we are going to divide the remaining 90 into 2. So we are having 45 and 45 here. So when you add 45 and 45 together, we are having 90 degree. Added to the 90 degree here, of course, you know that it's going to give us 180, which is the sum of the interior angle of a triangle. Now here, we have gotten here to be 1 unit and 1 unit because it's an isosceles right angle triangle. So we need to get this place, and this place is called the hypotenuse because this is where the right angle itself is facing, and we regard that line as the hypotenuse. Then wherever the angle is facing is our opposite. So the opposite can be this or this one, depending on the angle that we are considering, and the rest of the other side is the adjacent. Now we will have to obtain the value for the hypotenuse. Now, let's tag the hypotenuse to be x. Now, to obtain this value, we consider the Pythagorean theorem. We know that the Pythagorean theorem says that the hypotenuse square is equals to the opposite square, then plus the adjacent square. That is, the square of the hypotenuse is giving us the sum of the opposite squared and what? The adjacent squared. Now, as regards to this triangle, which one is the hypotenuse? Our hypotenuse is unknown and we regard it as x. So the hypotenuse is now x squared. Now, which one is our opposite? Of course, if you are considering this angle, here becomes our opposite. Or if you are taking any of it, this one can become our opposite and the rest of it is our what? Adjacent. So what we have here is equals 1 squared plus 1 squared. So we have x squared here is equals 1 squared simply means 1 times 1. 1 times 1 is giving us 1. So we have 1 here plus 1 squared again is 1 times 1, which is the same thing as what? 1. 1 plus 1 will give us 2. We have x squared is equals to 2. But remember, we are not looking for x squared. We are looking for just x, which is our hypotenuse. So how do we get x? By simply taking the square root of both sides. So we are taking the square root of both sides. We have x squared here is equals to what? Square root of 2. The reason for that is so that this square root here, we cancel this square. So we'll be left with x, which is what? Square root of 2. Now we've obtained the value for square root of for x, which is our hypotenuse. So I want us to redraw the diagram. This is what we have. This is our right angle. Here is 1. Here is 1. Of course, we have our 45 here. Here is also the 45. And we've gotten our hypotenuse, which is x, as square root of 2. Now, let's get the sine, the cosine, and tangent of the angle 45 degrees. Now, before we could do that, we should not forget our dear friend, SOHCAHTOA. Now, this means that the sine of an angle is equal to the ratio of what? Opposite and hypotenuse. Then the sine of the cosine of angle is the ratio of adjacent and hypotenuse, and the tangent of angle is the ratio of opposite and adjacent. So let's take the first one, which is sine 45 degree. What is the ratio of sine 45 degree? Keep looking at the drawing on the board. You find out how the sine is opposite over hypotenuse. Now, which one is our opposite? If you are looking at this angle, you find out that this is our opposite. Where the angle is facing is the opposite. And this one, which is facing the right angle, is our what? Hypotenuse. Or if you are considering this one, you find out that this is where the angle is facing. And this is our what? Hypotenuse, of which is giving us the same thing. So we are taking any one. So the sine of 45 degree is opposite over hypotenuse, which is what? 1 over root 2. So we have 1 over root 2. But if you are conversant with solved, you will know that you are not going to leave it this way. So we need to rationalize it by simply multiplying by root 2 over root 2. Now, 1 times root 2 will simply give us what? Root 2. Root 2 times root 2 will give us 2, because root 2 times root 2 is going to give us root 4, or we'd rather say square root of what? 4. And the square root of 4 is going to give us 2. That is why we obtain that root 2 times root 2 is giving us what? 2. So our sine 45 degree is giving us root 2 over 2. Then the next one is cos 45 degree. Cos 45 degree. Cos 45 degree is adjacent over what? Hypotenuse. So what is our adjacent? If I'm looking at this angle, this is the opposite, so this is my adjacent. I'm taking one as the adjacent, and the hypotenuse remains the what? The root 2. Or if you are considering this angle, you know this 45 and this 45, they are the same thing. So if you are considering this one, this is our opposite, and this one will become our what? This one will automatically become the adjacent, and this one is the hypotenuse. So they are giving us the same thing. So our adjacent over hypotenuse is 1 over root 2. So we have 1 over what? Root 2. But the same way, just like what we did here, we are not going to leave it this way, because this is solved. So we need to multiply by root 2 over root 2. So 1 times root 2, remember we are talking about cos 45 degree. So 1 times root 2 will automatically give us what? Root 2 over what? Then root 2 times root 2 is 2. Of course, I have explained that root 2 times root 2 will give you 4, and we give you square root of 4, and square root of 4 is 2. So we have 2 here. So cos 45 is giving us root 2 over 2. Then the next one is tangent of 45, which is tan 45. What is tan 45? Looking at our SOHCAHTOA, the last one, which is opposite over adjacent. Now, look at tan 45. Can you see 45 angle? This is opposite over adjacent. Or if you're considering this 45, this is opposite over adjacent. Of course, it's giving us the same thing. You can see it now. So what we have here is 1 over 1. And 1 over 1 is the same as saying 1. So tan 45 is giving us what? 1. Now, look, can you see what I'm saying? That sine 45 is the same as cos 45. The reason being that they are complementary angles. When we have complementary angle of sine and cosine, they will give you the same answer. Like here we have sine 45 is equals to root 2 over 2. Then cos 45 is as well giving us root 2 over 2. So tan 45 will give us what? 1. So let me bring them out so you understand them. The first one is sine 45. We have it that we have root 2 over 2. Then cos 45 degree, we have root 2 over 2. Then tan 45 is giving us 1. Now, thank you for this section, and please wait for this next section where we'll be talking about the angle of 30 and 60 degree and the rest of the other angles. Thank you.